So let's talk about variables and expressions in math. And in other words, variables are those letters in math. So, A plus B equals C. And most students in the beginning, when we talk about variables or letters in math, it makes them a little anxious because they've only had variables. They've only been using letters to read with, or to write with, and not seen them in mathematics, and wonder, why are they belonging in here? We need to be using numbers. But I remind students that you actually have been using variables since the first grade. For example, if you had 5 plus an empty box equals 10, that empty box is a variable. It's an unknown. So in the first grade, you filled in the empty box with a 5, and you answered it, oh, it needs to be 5. And so actually you were doing algebra in the first grade. We just didn't tell you were, because if we would have said 5 plus A equals 10, that could be really confusing to a first grader, second grader, third grader, because A is A. It means or A, and it's used in words, and to try to explain that concept to a young math student could be confusing. So we use little boxes or circles or blanks, but really what we're asking for is an unknown. So that's what letters are in math. They're just representing an unknown, and we can manipulate these expressions and or equations to figure out what those unknowns are. We can substitute values in for them to solve them for an answer. So let's talk about some different looking expressions and the different terms that they have and the variables that would be in those expressions. So let's say, for instance, you have 4 minus x. X is your variable. That's your unknown. In terms of this expression, the 4 and the x, those are called terms. They're terms of the expression, and this is called an expression and not an equation, because it's just a statement, it's just a sentence about math. It's saying 4 minus an unknown, but it's not saying equals to something. It's just saying we have 4 minus an unknown. We can't solve it. We can't solve and find x yet until we know that it's equal. So this is an expression. And the 4 is a term and the x is a term. The 4 actually, sitting there by itself, is called a constant. Just the number 4. It's constantly 4. And the minus x just means that the x is our variable, and that's an unknown. So let's take a look at the expression 5m plus 6 and discuss these terms and what's kind of different and unique about them. They're both terms. The 5m and the 6 are two separate terms. They're unlike terms. The 6, as you just learned, is called a constant, because it's constantly 6. It's never going to change. The 5m means 5 times m. In that, the m is your variable. That's the unknown. It varies. We don't know it yet. We might be told that it's something. We might be given some sort of solution set for it. We might be told that this expression is equal to something and becomes an equation and we can solve for it. But we just know that m is our variable. And the 5 sitting next to the n means 5 times m. That's the coefficient. And it's just saying that there's 5 m's. So in other words, it's m plus m plus m plus m plus m. But instead of saying m plus m plus m plus m plus m, we shorten it up and we combine all those m's and we say there's 5 m's, or 5 times m. So when 5 is sitting right next to the letter m, it means 5 times m. So this expression, if we were to read it entirely mathematically, it would say 5 times m plus 6. Other examples using variables and what they mean, you could just have two variables sitting side by side, like a, b. And when you have two variables sitting side by side, that means that it's a times b. Okay, and both of those are variables. It's a term as ab, and it means that the variable a and b are multiplying times each other. You could also have a variable like y over 3, and that just means y divided by 3. The variable is 3, you have a constant, or excuse me, the variable is y, that you have a constant 3, and y is being divided by 3. Now, often in algebra, we have to translate phrases into algebraic expressions, especially when we're dealing with word problems. That's kind of what it's all about. So if you had something like $3 more, so it would read in words, $3 more than the cost of a sandwich. As an algebraic expression, you could let any variable equal the cost of the sandwich, because we don't know that. That's the unknown. So we could say, okay, the cost of the sandwich is C, and then we have the $3 more than, and your keyword is more than, which means plus, right? So you'd have 3 plus C, or you could write it C plus 3. Okay, let's get a little fancier than this one. I typed out 2 more than $6 per hour, and let's change that to an algebraic expression. So keywords are more than, that's adding, $6 per hour. That would mean $6 times every hour that you work, right? So the unknown here is your hours. That's your unknown. So you could assign any variable to that. You could say h for hours, or x, or n, or whatever you'd like to do. We could just say h equals hours, and then we would put this out in an algebraic expression using symbols. So we write the number 2, more than means plus, and then $6 per hour, we would have to write 6 times h. And now in algebra, that 6 is a coefficient, so we would put 6h, which just means 6 times h. So we'd have 2 plus 6 times h. And here's another one, 2 miles less than the athlete ran. Keyword, less than. Unknown is we don't know how much they ran. So we could say, you know, let R equal the miles that they ran. And we have 2 miles less than the athlete ran. So that less than means a minus, but the trick here is that it's not 2 minus how much they ran, because then we would be in a negative zone. It's actually 2 from the miles that they ran. So we would write R minus 2. So when we want to evaluate expressions, we can replace the variable with known values and use the order of operations, GEMDAS, or PEMDAS, or please excuse my dear Aunt Sally. If you need to refamiliarize yourself with that, you should take a look at that video that I did earlier on PEMDAS. But we replace the variables with some sort of known value, and we can solve the expression or simplify it, or in other words, evaluate it. And there's a fancy property in mathy language that allows us to do this. And it's the substitution property of equality, and it says if 2 quantities are equal, then one quantity can be replaced by the other. For numbers a and b, if a equals b, then a may be replaced by b. Now there again, we're throwing some letters into math, and sometimes this makes people a little anxious. But if we just put some numbers into this and kind of showed it, if we had something like d plus 5 minus f, and I told you that you were given that d equals 16 and f equals 18, what it's saying is that, okay, because d equals 16, a equals b, I can substitute that 16 in for the d. Because f equals 18, that's my, you know, in my property of equality, that's my A equals B, then I can substitute that 18 in for F. So let's just show it, because that sounds still a little confusing. So I substitute in the 16 for the D, and the D plus 5 minus F. So now I have 16 plus 5 minus F, and I substitute in the 18 for the F. So now it's 16 plus 5 minus 18. I do my order of operations, which means I add and subtract left to right, whichever comes first. So I have 16 plus 5 is 21, minus 18, and the answer is 3. Let's evaluate some other expressions by substituting the replacement value in, using that substitute property of equality. So if I have 6 minus E plus F, where E equals 3 and F equals 9, I'm going to substitute those values into that expression. So I would have 6 minus 3 for the E plus 9 for the F. I use my order of operations, which means I have to solve left to right with the 6 minus 3 plus 9. There's no parens to simplify. There's no multiplying or dividing. So now I'm in the adding and subtracting zone, and I need to just go left to right. So 6 minus 3 is 3 plus 9, and the answer is 12. Now let's do one with some coefficients. So if I had 6s plus 2t, that just means 6 times s plus 2t, plus 2 times t. And I was told that s equals 5, or given that s equals 5, and t equals 8. We're going to substitute those values in. So notice that I'm going to use a open paren, closed paren, just to have you getting used to seeing that. So we'd have 6 open paren, 5 closed paren. Remember, if you've got a number right next to a parentheses in another number, that just means multiplication, plus 2 times open paren, 8 closed paren, so that just means 2 times 8. We do the multiplication first, so 6 times 5 is 30, 2 times 8 is 16, and we carry down that plus, and now we can do the addition, and 30 plus 16 is 46. So there we're substituting in replacement values in another expression where we had to do some multiplication. Let's do one with division. So if I had multiplication and division, if I had st all over 20, and I was told s is 5 and t is 8, we're going to substitute those values in, the s and the t right next to each other. You learned earlier that two variables sitting next to each other just means multiplication. So we would have 5 open paren, 8 closed paren. That just means 5 times 8 all over 20. And using order of operations, we want to solve what's on the top and then simplify it. That fraction bar is a grouping symbol. And once we do what's on top and on the bottom, then we simplify it. So 5 times 8 is 40 all over 20, and 40 divided by 20 is 2. Now let's do one with the parentheses. So what if we had r plus open paren 40 minus 3t, where we're told r equals 1 and t equals 8. So we would have substitute in the r value, so we would have 1 plus open paren 40 minus 3 times, and we substitute in the t value, 8. So I would do 3 open paren, 8 closed paren, and then another closed paren. So we've got to do what's inside the parens first. 40 minus 3 times 8, we got to do the 3 times 8, which is 24. And then we're going to subtract that from 40. So 40 minus 24 is 16. And then we pull down that 1 and add 1 to it, and we end up with 17. And sometimes you get expressions that involve several variables, like c plus open paren 5b minus 2a, and you're told that a equals 4 and b equals 8 and c equals 12. Now we're going to substitute in all those values. So we have c plus open paren 5b minus 2a, so the c is 12. So we're going to write c plus open paren 5 times, I'm going to use a dot for now just to kind of mix it up, 5 times 8 minus 2 times A, so 2 times 4, so 2.4, and then close paren. So we have 12 plus open paren 5 times 8 minus 2 times 4 close paren. So we need to do the multiplication inside our parentheses first. We end up with 40 and 8, and we pull down the subtraction. That's still in parentheses, so we have to do that next. 40 minus 8 is 32, and then we pull down the 12 plus at the beginning, and 12 plus 32 is 44. So we're substituting in those replacement values, and then we're using the order of operations very carefully to evaluate these expressions. So here's a real-world application problem, kind of bringing all this together, of using variables to find an unknown or to represent an unknown, writing an expression, translating English into an algebraic expression, and then using that expression by plugging in some sort of replacement value for the unknown variable and answering the question. So it says, a company rents a houseboat for $200 plus an extra $30 per day. A, write an expression that can be used to find the total cost to rent a house, and then B, suppose a family wants to rent a houseboat for 6 days. What will the total cost be? So a company rents a houseboat for $200 plus, that's a key word, plus an extra $30 per day. Okay, so there's some more information that's kind of key. Write an expression that can be used to find the total cost to rent a house. So we know how much you start out with. We know that it's $30 per day. What's our unknown? Well, our unknown is how many days. So we could let D equal the number of days. You could assign a variable, or you could assign X, doesn't matter, or N, just any variable. So we would have $200. So part A would be $200 plus 30. Now what are we going to do here? Well, we're going to go 30 times D, because we're going to go 30D, because we know that it's 30 times how many ever days there were. If we were there for 5 days, 30 times 5. So there's our expression. Then suppose, in part B it says, suppose a family wants to rent a houseboat for 6 days. What will the total cost be? So now it's telling you that they're assigning a value for D. They're saying it's 6. They're saying D equals 6. Mathematically, that's what they're saying. Houseboat for 6 days. So you're going to plug that in your expression. So you're going to have 200 plus 30 times 6. And so you do the multiplication first, and you get 180 plus that original $200. So to answer the question, what will the total cost be? It's going to be $380. So using the information from that last real-world problem, we had 200 plus 30D, which was our expression. So we're kind of reviewing the information that we've learned. That's an expression. And it has two terms in it. It has 200 and the 30D. The 200 is a constant. The 30 times D, the 30 is your coefficient, and the D is your variable. And then they solved it. It was solved by saying, if we were there for 6 days, how much would it cost? So that 6 is your replacement value for D, and we used the substitution property of equality to do that, saying, hey, well, if D equals 6, then we can plug 6 in for that D and evaluate this expression. And then we just use order of operations, and you had to do the multiplication first at 30 times 6 for 180, and then you were able to add the 200 to it to get the 380. So you learned about variables and expressions and terms of your expression, and that a coefficient, the 30 times the D, the coefficient tells you that there's 30 D's, and then you learned about the substitution property of equality, where if you're given that D equals something, like in this case D equals 6, you substitute that number 6 in for D, and then you evaluate the expression using order of operation to answer the question.